Gephi is an open source visualization software and allows users to explore and analyze graphs in networks. For example, Gephi can be used to find connections in social networks, diseases, or infrastructure, and there are tons of possibilities other than those. In this video, I'm going to show you a quick example of what Gephi can do and why and how that can help your business. The example I'll be using is a pre-made data set that you can find on Gephi.org. It is data showing the topology of power plants in the western United States power grid. And you would open a new project. So do that, and then you'll go to File, Open, and click OK. And see, it's a cube. Go over Layouts. Layout is this part right here. I will be using Force Atlas 2. Run that, and you can see that it explodes. This is the main part of Gephi. This is what the whole program runs around, is this graph. All the dots you can see are nodes, and all the lines connecting the nodes are edges. Next, we're going to calculate some metrics such as average degree and network diameter. So we'll go to the data laboratory. To see the visualization of the data, you have to run metrics. For this, I'll go to Window, Statistics, and I'm going to run average degree, and you'll get a graph when you run it. And I'm going to run network diameter. Here you can see that you can organize the data by clicking on these. Next, we're going to go over back to this. I'll quickly explain what these two metrics mean. The degree for a node is how many edges are adjacent to that node. The average degree is the average of how many edges are adjacent to all the nodes. The network diameter is the diameter of the longest graph distance within the network. So two nodes that are the furthest apart while being connected by an edge. The distance of that edge is the network diameter. So next I will go over ranking. On the top left window, you can see it is labeled Appearance. We are going to rank nodes by their size. So nodes, size, ranking, and then I'm going to choose degree. And I've scaled these sizes up to make the nodes larger and more visible. To help you understand what this means, the larger the node, the more connections it has to other nodes. In the context of our data with power plants, a node represents a substation, and an edge is connecting those substations. The larger the node, the more edges are coming out of that one node. Otherwise, the larger the substation, the more transmission lines are coming out of that substation. Next, I will rank color by closeness centrality. So we'll go to Node, Color, Ranking, and Closeness Centrality. Apply. Closeness centrality is the average distance from a given node to all other nodes in the network. Here we have a gradient of green. The darker the shade of green on a node, the more central that node is to the network. So the dark green nodes, such as these, are more central to the power grid in the western US. Ranking the data helps identify which substations are more important to the grid. Over on the right, you can see the Filters tab. We will use that by clicking Filters, Topology, and Degree Range. Here you can see there's a slider. Moving the slider around changes what nodes we can see in our graph. So if we wanted to see only the larger nodes, we would move the left part to the right and then filter. So there's only one. So if I moved it, so there's more. Those are the larger ones. You can see it all coming together here. And then if we only wanted to see the smaller nodes, we would go this way, and the larger nodes would go away. This slider lets us filter out substations by how many transmission lines they have. Gephi is a great tool for you to use if you want to visualize your data and making data easier to understand and look at.